Hey physicists, what's the crack? So I got asked if I could do some more VT graphs. Okay, so VT is your velocity time graphs. So this one is, I want to do one for a ball that's been dropped and it bounces. So for me, I need pictures because that helps me out. Okay, so for me, there's a ball in his hand, he drops it and it bounces. I know when it's in your hand, its initial velocity is going to be 0, right? It's not moving. As I drop the ball, we know the ball is going to get faster and faster and faster as it goes down. And remember, what we're always going to do here is down is always going to be negative numbers, up is always going to be positive numbers. So as this goes down, that negative velocity there is going to be a really high number. It's going to be really fast at the bottom. When it hits the ground, we know it's instantly going to change direction. It's now going to be moving upwards, so we know it's going to be a positive number for velocity. And that positive number for velocity is going to be really high. And as the ball starts to come back up towards my hand, it's going to slow down, slow down, slow down, slow down, to eventually come back towards 0 speed as it hits my hand. So when I sketch my velocity time graph, there's my velocity and there's my time graph. We just said at the start, when it's in his hand, his velocity is 0. So it's going to mark that point there. The velocity is 0. Then what's going to happen is the velocity is increasing in the negative direction. So here's my negative part of my axis. So the velocity must be increasing in the negative direction. So we get some really negative number. And then we said as soon as it hits the ground, its velocity is now positive, but it's a really high number. So somehow now we have to be up here in the positive region and a really high number of velocity, so up here somewhere. And then we said over time, that positive velocity is going to decrease, 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 back towards 0. Okay? Then the other fact to remember is that the gradient of a velocity time graph always gives you the acceleration. Okay? So the gradient of velocity time graph always gives you acceleration. And we know that if I was to drop my ball on Earth, the only force acting on that ball since I let go is the force due to gravity. And we know gravity always has the same number of 9.81. But because gravity is pulling things down, that's why it's negative 9.81. So when I do my graph here, the gradient should always be the same number, and it should be a negative gradient. Okay? So for example, that would be a positive gradient, that would be a negative gradient. So I need to have a negative gradient all the time. The look here doesn't make sense, and that's true because it started here, we said we're going this way, and as soon as it hits the ground, it's got a positive velocity, and it's going to go this way. So the gradient of those two lines should be the exact same, so they should end up being roughly parallel lines, okay? And then if you want to show that this was an impulse, a change in velocity, you could just do a dotted line. So that shows me that there's a big impulse here, a big change when it hit the ground, from going from really negative high velocity to really positive high velocity because it's changed directions. So again, the gradient of those lines is going to be negative 9.81. So that's grand.